Hello, dear learner. Welcome back to our lessons. As usual, our YouTube channel account is Wilfred Mumanyi Onkangi-Kiongozi. And due to public demand, Lanet Secondary School, class of 2023, has requested me to do something very interesting on matrices and transformation. So sit back, have somewhere to write, and as usual, concentrate in this lesson. I want to take you through matrices in Form 3. And you know, the climax of this chapter is when you are able to use matrices to solve simultaneous equations. Remember, you have done some bit of a formula that are used in solving simultaneous equations. You did 3 formula in Form 1. The first one was substitution. You also did elimination. You also did the third one, which is graphical. And now, this one is now a star. We're calling it matrix method. So this is going to be the climax of this chapter. And I would like to tell you that the exam that you sit for, you will not lack this question. This one of matrices or matrix method of solving simultaneous equations. Remember, the whole chapter, and I have to tell you this, that chapter will give you, let's say, 4 marks. This one is not like the chapter in Form 4 called matrices and transformation that will have questions that have 10 marks. This one will give you 4 marks. And so, I would want you to go walk with me, have somewhere to write, so that at least you get the basics in preparing yourself to solve questions or solve simultaneous equations by the method matrix method. So write the following notes. We start with basics. Basics. In this chapter, basics, we will look at what a matrix consists. A matrix consists of rows and columns. Consists of rows and columns. The rows are horizontal. The arrangement of the rows is horizontal, while the arrangement of the columns is vertical. I want to make this lesson very simple indeed because we want to do a summary. I'll give you an example of a row and show you how the two are arranged. For example, I will say A, B, C, D, and then I will use either the round brackets or square brackets. So now, from A towards B, this one is a row. So this is a row. From B towards D is a column. From C towards D, running horizontally, is a row. From A towards C is another column. So we have 2 rows and 2 columns in this kind of matrix. So we can use round brackets, or square brackets. So you can use either. So there is what we call an order of a matrix. I hope you've written that one. Can as well do away with it. So we go to the second basic thing. There is what we call order of matrices. Order of a matrix. So you will hear people say this matrix is of a given order. So how do we get orders? The number of rows and columns determine the number of rows, and columns determine the order of a matrix. The order, which can also be interpreted as the arrangement of a matrix. So we have several types of orders, and I will give examples later on. But I gave you an example of a matrix whereby I used letters A, B, C, and D, and I used the round bracket. Allow me to use a square bracket now, and then tell you what A, B, C, and D mean. A, comma, B, comma, C, and D are elements of this matrix. So these are elements, and now the positioning of these elements will now determine the kind of matrix that you have. In this, I want to take you back to the rows and columns before we talk about the types of matrices or types of orders in matrices. We can use these letters. I said from A to B horizontally, that is a row. Another one is from C to D horizontally, those are rows. But from A to C vertically, these are columns. And of course, B to D is another column. So this is what we say. If you want to check the positioning of these elements, we will say A is in the first row, first column. A is in the, let me use this one here, first row, comma, first column. That is the position of element A. We go to B. B is in the first row, comma, second. So let us call this one column 1 and this one column 2. Then this one row 1 and this one row 2. So B is in the first row R1, second column. Quickly, we go to C. C is in the second row, second row, first column. And then we go to D. D is in the second row, comma, second column. Please mark the position of elements. Position of elements in a matrix. That is how we discuss that one. We have types of matrices depending on the number of rows and columns and the way they are arranged. Very quickly, we have the first one. We shall do a few. We will do a square matrix, we do a null matrix, and maybe come to the end of our lesson. I just wanted us to understand how elements are arranged in a matrix for our first video. What is a square matrix? Something new. We are slowly getting out of the basic things to a bit more abstract things. A square matrix. Sorry. A square matrix. A square matrix. This is a very simple matrix, and the one that I've given you in form of letters is an example. This is a matrix in which the number of rows and the number of columns is the same. So this is a matrix in which is a matrix in which the number of rows, equals, I want to write this one in capital letters, equals and underline the number of columns. And here, students, we can give examples. We can give examples like the one I gave you. I have, let's say, T, X, Z, J. Then use the round brackets. In this case, we have the first row, row 1, second row, row 2, first column, column 1, second column, column 2. The number of rows, we have 2 rows and 2 columns. So this one, in terms of order, we shall call it a 2 by 2. 2 by 2. But mathematically, we don't have by. This one is grammar. We say 2 by 2. 2 times 2. 2 rows, 2 columns. We can give an example of another one. Maybe 3 columns, 3 rows. Square matrix. We have A, B, C, D, E, F, G, H, I, for instance. We have 1, 2, 3 columns. Then we have 1, 2, 3 rows. We can even have, so this one is a 3 by 3. We can have a 4 by 4, and so forth and so forth. That is what we call a square matrix. Our last type of matrix, we have a null matrix. A null matrix. A null matrix. People are fond of talking about null, can also be referred to as zero matrix. Yeah, when you say something is null, some people say void. So a null matrix is a matrix in which all its elements are zero. So a null matrix, all the elements are zero. So this is a matrix. This is a matrix. A matrix with all its elements being zero or zeros. Then we have some very important points to note. For example, I have this kind of matrix, and this is a 2 by 2. I can also have another one like this. When all the elements in this matrix are zero, we call it a null matrix. And we have maybe a point or two to note before we come to the end of this lesson, so that we prepare ourselves for the next objective. These are very crucial points to note. So we note the following. Number 1, 2 or more matrices, 2 or more, Roman 1, 2 or more matrices are said to be equal if they are said to be equal if they are of the same order. If they are of the same order. And that's all the end. And their corresponding elements and their corresponding elements are equal. So that is when we say two matrices or even more are equal if they are of the same order. By the way, I need to do something little about a different order apart from a 2 by 2. We may have a matrix, maybe A, B, like this. This one is a matrix. Let me use the square bracket. This one. And in citing the order of this matrix, we begin with the rows, then we write the column. So this one has only one row. Rows run, it has two rows. It has two rows, yes, two rows. The row that goes with A, that one of B, and one column. One column. So this one is a 2 by 1 matrix. That's another example. We can have several others. Actually, we can have A, B, C, D, E, F. Let us also cite the order of this. How many rows? 2 rows. This is a 2 by columns are 3. This is a 2 by 3. So these are maybe a few examples that I should have included here. So when we go back to our statement here, we say if our matrix A, B, C, D, this is a 2 by 2, if it has to be equivalent to another matrix, then it means the elements of this position A shall be equal to the elements of the other matrix. For example, 6, 7, and maybe 8. So if these two matrices are equal, then it means element A is 4, element B is 6, element C is 7, and element D is 8. I have used similar symbols to illustrate that, and two or more matrices are said to be equal if they are of the same order. This one is a 2 by 2, and this one is also a 2 by 2, so they are of the same order. The number 2, the last thing is the elements, corresponding elements. So A corresponds with 4, and the rest of the elements as we put it. The last point to note, how do we denote matrices? How do we denote a matrix? This one you'll find it in the equations that you sit for in the exam. Point number 2 to note. Roman 2 points, and the last one here. We denote matrices using a bold capital letter. So matrices are denoted using bold capital letters. What do I mean? I mean, if you've been told, given that, for example, given that matrix A, so should be capital and bold, is equals to, for example, 3, 2, -1, 6. So the point is very easy here. It is not even examinable. In the exams, you'll find A or any other matrix that you're given being denoted in bold capital letters. I know you are now good to go. We now want to dig into a few calculations in matrices. These was a very good introduction, and I hope you are going to still work with me. Have a nice time.